All right, welcome to one of our harder lessons we're going to do all year. Absolute value inequalities. So absolute values, those things that a lot of us struggled with, at least remembering the two solution rule in chapter 1, now paired with inequalities. Again, a lot of the algebra rules stay the same. There's just a couple little niche things that we have to know to successfully solve these problems. This is going to be a 2-day lesson. So let's define an absolute value inequality quick. So the definition is actually really straightforward. It's an inequality, so what we've been using all unit, that contains an absolute value expression. The inequality symbol decides if it's going to be an and inequality or an or inequality. So absolute value inequalities are another way of writing the 2.5 lesson compound inequalities. Now, I don't particularly find much value in this because you never see compound inequalities written this way. Realistically, even me with computer programming, when this would apply, instead, I just write out the compound inequality. I usually don't even use the absolute value because it's not necessary. There's always another way to write this. But it's still something that worth looking at, and it's not the end of the world if this is one of the few things we don't understand at a 100% deep level. So this is going to be pretty abstract, a little bit challenging, but it's hard for me to show you too many real applications for it, because this is one of those weird things in math that, for being honest, not a whole lot of professions use. We need to understand the concept, but strictly following the algebra, hopefully that just happens over time as you're forced to use this stuff more and more. Let me just hold this up here for a second, and I'd like if you just pause the video and read through it or listened as I talked. But this is a really clean, worked out example for these problems. So what we start with is getting the inequality by itself. Get the absolute value alone is goal 1. Goal 2, decide if it's and or or. So the number on the right is actually the error, if you remember writing out absolute value word problems. If you're less than the error, that means it's an and inequality. You're inside of a range. If you're greater than the error, that means it's an or inequality. You're outside of the range. So it would point in opposite directions. So this one would be an and inequality. That's why I wrote the word and in that next step for goal 3. And in goal 3, it kind of just looks like solving an absolute value equation. For the side you make negative, and the focusing is a little rough right now, but the side you make negative, if you remember splitting up absolute value equations, that side has its inequality symbol flipped. So let's write down and do our own example quick. All right, here we go. Now, if you're able to do this problem and feel comfortable with it, you are in a good spot. So, looking at this, goal 1 was to get the absolute value alone. Goal 1, abs val alone. That's already done for us. So I'm going to check that box. All right, now we look at goal 2, decide and or. I'm smaller than the error. That means this inequality is going to be shaded towards the middle. I'm going to be inside of the two endpoints. So we'll graph this at the end. But this is going to be an and inequality. And because I'm smaller than the error, I am interpreting this too as the error in a word problem, how far off we're allowed to be. And the 7 is the goal, although we would usually do minus the goal. So this would actually be a goal of like -7. I don't know, this is just a naked problem so that we can practice the steps, but this would be an and inequality. I'm supposed to be smaller than the error. That means I'm inside of the two endpoints. All right, goal 3 is to actually separate the absolute value. And so this is where we have 1 that's just normal. X plus 7, use the same symbol, less than or equal to 2. So this is the normal side. I didn't make any changes. This is the flipped side. I'm going to use a -2, and I also have to flip the inequality symbol. X plus 7 greater than or equal to -2. Look at the changes. The symbol is flipped, the number is opposite. The symbol is flipped, the number is opposite. That's goal 3. Goal 3 is to separate the absolute value and if you look at the notes that I handed out or look at the answer key for the notes, it'll have all this stuff filled in for you. Separate the absolute value into a positive and negative answer. Flip the symbol for the negative. Flip for the negative. All right, I'm writing this in a really shorthand text, but these goals are written right on your paper. So now we solve each of these separately. If you remember, with absolute values, they often have the same steps. So the first one ends up being x less than or equal to -5. The second one ends up being x greater than or equal to -9. And then that's goal 4. Solve each separately. At this point, they didn't really affect each other anymore. Step 5 is graph. All right, so graphing, we're just going to draw ourselves a number line. And we need -9 and -5. Put them in order. -9 is smaller, so it should be further left. They're both or equal to symbols, so they're both going to be filled in. And without referencing the and, I would still graph towards each other because I'm bigger than -9. And I'm smaller than -5, and it graphs together. This is an and inequality. Okay, so this is the graph. Now, if we try any number in here, like let's say I throw in -8. That's between these two. Based on our answer, it should work. Let's look. -8 plus 7 is -1. And then the absolute value of -1 is just 1. Is 1 less than or equal to 2? Absolutely. All right, so anything inside of this should work as a solution. That's what makes it an and inequality. This is just like the compound inequalities that I asked you to solve the other day. Okay, so if I wanted to write this like one of those, it would be -2 less than or equal to x plus 7 less than or equal to +2. If there's some way I can get you to understand that these are the same thing, then I have done my job. So these are actually the same thing, but I always choose to represent it this way when I'm doing something like my programming. All right, but we still need to understand the concept here. Absolute value doesn't care about positive or negative. That's what results in the compound inequality. All right, there's something to understand here, and if you're able to grasp that, I've done my job for you. All right, let's look at some more stuff. Now, just like every other dang thing we've done in this class, there's been a situation where there's special solutions. Take a quick second, think about why this might be a special solution. I really want you to think about it before I just tell you, because this is a very conceptual thing. This is an absolute value. What do you know about absolute values? You should know that they cannot be negative. When I plug something in, if it comes out to a negative number, the absolute value symbols turn it positive, so the actual result cannot be negative. Well, what's the only stuff smaller than 0? Smaller than 0 means all negatives. So here I'm saying that this absolute value that can't be negative has to be smaller than 0, and that is just not possible. So this is a conceptual thing. If I put any negative number here too, like a -5, it also wouldn't work. 0 is kind of like the borderline. If I had less than or equal to 0, I could find my one answer where it's equal to 0, but I can't take any of the negatives. So we have to understand that this can't give me any negative answers, but it's telling me it has to be smaller than 0. All right. So I keep going around in circles trying to get you to understand this is a no solution. Now mathematically I can show you this by solving it, but what it would come out to is I have to be greater than and smaller than the same number. Can I have more than $10 and less than $10 at the same time? No, I cannot. That's why this doesn't work. All right, there is actually no solution that's going to work here because I'm trying to tell you an absolute value is negative. That was a problem back in chapter 1. It's a problem now. This symbol just makes us interpret it ever so slightly differently. So I'm not even going to do any work on this problem. This is just a conceptual thing for us to understand. Now, we had a no solution problem. You gotta assume there's going to be an all real numbers problem. And this is that. So let's talk about this again. This has to be positive because it can't be negative. I'm changing the wording this time on purpose. So this thing has to be positive no matter what I plug in for m. Greater than -2 is saying, well, bigger than -2. Now my question for you is it possible to find a positive number smaller than -2? That's my question for you. It's a weird question, but no, it's not possible. It's not possible for a positive number to be smaller than a negative number. Positive numbers are always going to be bigger than negatives because they're just on the right side of the number line. Negatives are on the left, positives are on the right. Right's the bigger stuff. It's not possible. So it is not possible for us to find something that doesn't work. There is no m value that is not a solution. What does that kind of sound like to us? Everything is a solution. All real numbers. This is an all real numbers. So if an absolute value is bigger than a negative, that's always going to be true. If an absolute value is smaller than a negative, it's never going to be true. So those are the two situations. All right, that might be a little hard to remember, but if you get yourself to understand what absolute values are and how inequality symbols work, then you might be able to piece it together for yourself. Okay, this isn't a rule you have to memorize if you get yourself to the point where you understand the individual stuff well enough. So when you see something weird like this and you try to solve it and you plug in an answer at the end and it doesn't work, well, then you should know that there's something wrong. Or in a problem like this, when everything works and it ends up crossing over in this direction when it's supposed to be an or inequality, there's just weird stuff that happens. The deeper you can understand the math, the better job you can do understanding the weird stuff. All right, let's do another example that actually has an answer. We'll leave the realm of abstractness for now. So here's a nice problem that makes us actually do some math work before we split up the absolute value. All right, so goal 1 is to get the absolute value alone. So we're going to treat this absolute value like it's one thing that we want to solve for. Remember our reverse order of operations strategy? Get rid of stuff following reverse order of operations. So I'm going to subtract my 1 first. Divide by 4. We cannot use the distributive property. Remember that little rule. It's a special pair of parentheses, so we got to treat it special. That's why step 1 is to get it alone. Okay, that looks like it's by itself, so I'm going to check off goal 1. Goal 2, and and is the less than, or is the greater than. So mine is an or inequality. And I'm going to draw my squiggle. That's goal 2 done. Goal 3, I have to separate it into the positive and negative. So I've got my normal side on the left, 2x minus 5 greater than 5. And my flipped on the right, 2x minus 5. Predict what I'm about to write down. So flipped symbol and an opposite number. Instead of greater than 5, I have less than negative 5. Then we solve both. Going to take roughly the same algebra steps. They both started with a plus 5. Don't freak out when you see this 0. 0 is just a number. Divide by 2. Divide by 2. What's 0 over anything? It's just 0. That's not hard. I have some people that would write no solution there because they're just like, oh, whoa, but it's 0 and it can't be 0. It's just 0 is just a number. So these should be my 2 inequalities. And this is an or, so I should expect them to shade opposite ways on the graph. So let's get my 0 and let's get my 5 in order. Open circles because they don't have the or equal to lines. Now I'm bigger than 5, so I'm going to shade to the right. Ooh, my marker's dying on me a little bit. There we go. And smaller than 0. So we should have expected this. I'm happy it happened. Knowing it's an or inequality, I should expect it to go opposite. And should cross over, or should go opposite directions. And there we have it. Another full example done. So the goals that I guess I forgot to keep checking off: separate the absolute value, solve each graph. The goals are what you should use as your strategy to start these problems. You should always have something in mind, and this is kind of how I want you to organize your thinking. Whenever you see an absolute value inside of an inequality, I want your mind to go here. And while we're practicing this for a couple of class periods, you can have the notes out in front of you and practice with the steps. So, all right, keep any questions you have for class. I know we only got through a few problems, but honestly, these are some of the longer problems we're going to do all year. So get through this, and then we'll have a little bit of an easier time in chapter 3 and 4. All right.